Welcome to part 2 of my ePort 13 video. So here in this video, I'm going to be demonstrating the new microprocessor that I've created, which includes a control module, which you see up here, and the ALU subcircuit that I have created and demonstrated in the previous video. So let me go and just explain the control module real quick. So the whole point of this control module is so that this circuit, this microprocessor, can be ran automatedly, rather than manually. Because in the former microprocessor, everything had to be controlled manually. If you wanted to read or write over some inputs, you need to manually hit the pin. You have to insert your bits, send them off, select, and everything just had to be ran manually. And here, all you really have to do is just input your pins, make sure your S switch is on, make sure the address inputs are right, as well as which mode you are selecting. So let me go ahead and just start. I'm going to go ahead and just demonstrate the problem from the first week in our former microprocessor. So what we had first done was add 5 and 3. So binary 5, I'm going to insert here in ROM 0, 101, add that and 3. Here we go. And from here, I want to do addition. So to do addition, you have to go over here to the ALU subcircuit, and the mode to do addition is 1. So just switch this to 1, and then we're going to go up here to the control module, and I want to send the final sum of 5 plus 3, which is 8, into RAM 7. So I'm going to go ahead and do RAM 7. I'm going to input that here in address 3. So 1, 2, 3, 4, 5, 6, 7. And I use inputs from ROM 0 and 1. So I'm going to keep the first address at 0 to represent ROM 0, and the second address I'm going to do 1 to represent ROM 1. And from here, I'm going to go ahead and trigger the S switch. Here's the clock. I'm going to go ahead and let the clock run automatically by hitting auto tick. So let's go ahead and see how this works. So we can see the pins are being sent through the data bus. So there's 5, there's 3. They both pass through the demultiplexer, and we can see that 3 gets sent up here to input A. Everything is stored in the B register, passes through to the accumulator, which then gets sent down to RAM 7. There is my final sum. 5 plus 3 is 8. You don't need to keep the S switch on to continue the run. I'm going to go ahead and turn off the clock for now. And what I now want to do is I want to use what I have stored in RAM 7 and use that to create a new final answer and store into RAM 5. So basically I'm going to do 8 minus 3, and I'll get 5. So I want to get that output and send it into RAM 5. To do so, for the subtraction, I need to go back down here and switch modes. So I'll need to circle through all this again, back to 0 to do subtraction. Up here at the address, I just need to switch the pins. So address 3, I want RAM 5, so I'll move this to 5. Address 1, I'm going to do, let's see, what do I want to use? I'm going to use ROM 2. So ROM 2 I will set to 3. And input ROM 2 here in the address 1 pin. And this second address pin, I'm going to use RAM 7's information. So everything is all set. I'm going to go ahead and turn off the clock for now, hit the S pin, and just move down here so we can watch the bits being sent through. and watch them go on to RAM 5. So let me go ahead and hit the clock. And there we go. So what I just did was I did 8 minus 3. 3 was in the ROM, and ROM was sent up and around by using the address pins. So just to quickly go ahead and run through everything, the inputs that we use for all these modes come from ROM. ROM is sent through the demultiplexer and sent through the B register once we have the S switch on and the clock is running like it is now. And we also have to be sure that we have the proper mode selected through this peer pin. The data, when it passes through the ALU and it determines which mode we're in, it gets sent to the accumulator register, which is sent down to RAM, which is holding on to the data for us for now on these registers. And you have the ability to use whatever data is in the RAM registers, so long as you have everything routed properly. Like I had before, I just used the data that I had in RAM 7 to do some subtraction. As you can see, I kept these inputs triggered because unless I have the address routed and connected to the ROM 0 or 1, the inputs here are pretty much useless. When I had done 8 minus 3 from ROM 2, all I really had to do was make sure it was routed correctly. I wanted to send the final product of that subtraction problem into RAM 5, so I input RAM 5 here, is routed to RAM 5. Right here in address 1, I made sure to route that to ROM 2, I apologize, ROM 2, so that data that I had in ROM 2, which is 3, was sent up over here into the demultiplexer, I apologize. It's routed through here. And I wanted to route the data from RAM 7 and use those two numbers together to send them off into RAM 5, which is the final product of 8 minus 3. As you can see, everything is connected all together. You can't have one piece without the other. That is my final microprocessor. Thank you so much.